All right, so looking at number 4 for 3.1, we have a quadratic function. And the first thing that we want to do is be able to put it in vertex form. There's a few different ways to do it. One way is by completing the square. The other one is using the vertex formula, which comes from completing the square. If we practice the completing the square, we could work on that. So the first thing is that we want our lead coefficient, that -3, factored out of the first two terms. And then we're going to add something to complete the square. We'll have to also minus that something and then add that 52. So just kind of keeping that same format. As I write that little parenthesis, I'm actually going to erase that. Because we have the coefficient in the front, we're going to have to multiply whatever we subtract by that number before it comes out. So I'll just set that inside. So we take -3, divide by 2, and then square it. That's how we complete the square. That would be equal to 9/4. So we're going to add 9/4 and then minus that 9/4. And so the purpose in doing that was because now these first three terms, it's not that pretty, but it will factor to x minus that thing that we squared, 3/2. And so that's the factored part. And so the -9/4 that's sitting out there, we're going to have to multiply that by that 3 in order for it to come out, because this -3 really kind of distributes. So it has to sit in the front here because we're not going to distribute it into that trinomial that we just came up with, but we want to kick that -9/4 out. So -3 times -9/4 makes us really have, this will become like -3/1. That's positive 27/4, and we'll add that with that 52 still, so that's still coming along. So we need to combine these numbers over here. You can use a calculator or try and make them have the same denominator, which would be 4. So we have 52 times 4 is going to be 208. So when you combine those together, it's going to be 235/4, or you can write that as a mixed number. And the rest of the function is sitting right here. So this is our vertex form. So then we can also write it with decimals if that makes you feel a little bit better. This would be -3x minus, that would be 1.5 squared plus 235 divided by 4 would be 58.75. So then from here, because it's in vertex form, which is y equals a times x minus h squared plus k, you can see that the h is that 1.5 and the k is 58.75. Or if you think about it in terms of transformations, it's shifting to the right 1.5 and then up 58.75. So that would be the vertex. Again, you can keep it as those fractions or as the decimals. Now those are nice decimals. They're ending. If you end up with a decimal that is not a terminating decimal, you need to keep that as the fraction, because otherwise you're going to be approximating those values. All right, so we identified the vertex, we found the vertex form. For the next step, we want to determine the x-intercepts. So the x-intercepts are where we cross on the x-axis. So remember, that means that if we're going to touch the x-axis, we have a y value of 0 for those x-intercepts, which in this case, it's really our outputs, or our function value is 0. So we're going to write 0 equals -3x squared plus 9x plus 52. And so we can solve that a couple different ways. We could try and factor that. And so if we try and kind of do the x factoring, you'll end up that actually doesn't work. So the other way that you can solve a quadratic is using the quadratic formula, which says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so to plug into this, we know our a is -3, our b is 9, and our c is 52. So we're going to write -9 plus or minus the square root of 9 squared minus 4 times -3 times 52. This is all 2 over 2 times -3. And so as we simplify this, this will be -9 plus or minus the square root 9 squared is 81. And then over here, this minus 4ac, if we take -4 times -3 times the 52, it'll end up being a positive 624 over -6. And so if we combine 624 plus the 81, it's going to be -9 plus or minus the square root of 705 over 6. Now we can try and simplify that radical a bit. So this 705, we can see if we could break that apart. The digits add to 12, which is divisible by 3. And the rule for divisibility for 3 says if the number or the digits add to something divisible by 3, the whole number is. So kind of playing around with the calculator, you could find that as well. So it's 235 times 3. And then 235 follows that same rule. So divide by 3 again. Does it work? 8, 9, 10. Oh, nope, that's 10. So let's divide by 5. So 235 divided by 5 will be 47, which is prime. So we're kind of just stuck there. So my x-intercepts then are going to be -9 plus the square root of 705 over 6. And we have -9 minus the square root of 705 out of 6. And so those are the actual x values. If they want you to write them as the points, so pay attention to what it's asking you for, we could write the coordinates. So again, it's just the x values written as those kind of not nice radicals. And make sure you put a comma in there. -9 minus square root of 705 over 6, comma 0. Okay, so that's how we find the x-intercepts. If you need help with any other part of that, let me know. Hope that helps.